Okay, so picture this. You're standing on the shore of Lake Maracaibo in Venezuela.
Ah, beautiful place.
It is, and every night
Yeah.
you're watching this crazy lightning show. It's not fireworks.
Nope.
It's lightning.
Mother Nature's fireworks.
Exactly, like 250 bolts every single day.
Almost every day of the year, yeah.
Yeah, that's the Catatumbo lightning phenomenon.
Yeah, that's right, that's right.
And that's just like a taste of what we're going to be looking at today.
A little teaser.
All the science and myths and surprising realities of lightning.
Yeah, and we've got this great stack of Wikipedia articles all about lightning.
Oh, perfect.
Our mission is to pull out the most interesting stuff.
Okay.
Get ready for some myth busting.
I love it.
Mind-boggling facts and
Yeah.
a whole new appreciation for this powerful force of nature.
Well, I'm ready to be electrified.
All right.
Let's start with the bolts from the blue, you know?
Oh, yeah.
That always seemed kind of spooky.
Yeah.
They seem like they just come out of nowhere.
You and everyone else. But here's the thing. Those bolts are often associated with positive lightning, which is a whole other beast
Okay.
than the negative lightning.
Oh, okay.
Most people don't even realize that positive lightning can pack up to 10 times the energy.
Wow.
And that's why they can strike so far, miles away from the storm cloud, seemingly out of the blue.
So they don't just look dramatic.
Exactly.
They're actually more dangerous.
Exactly, because they often strike outside the storm's boundaries, right?
Right.
So they catch people off guard.
Okay, well, I'm officially adding bolts from the blue to my list of things to be extra cautious about.
Yeah, good idea.
But hold on. How does a thunderstorm even become this electrical powerhouse in the first place?
Yeah, it's a great question.
I mean, I get that it's about charge separation, but it's always seemed kind of magical to me.
It's not magic, but it is pretty amazing.
Yeah.
So picture this. You've got these powerful updrafts inside the cloud tossing around tiny ice crystals
Ah,
and grapple.
that's soft tail.
That's soft tail, yep, you got it.
Okay.
And these collisions, they cause the particles to become electrically charged.
Huh.
So the lighter ice crystals, those are positively charged. They get swept up to the top,
Okay.
while the heavier negatively charged grapple sinks to the bottom.
So you've basically got this massive electrical imbalance just building up.
Exactly, and that voltage difference between the top and bottom, it grows and grows.
Uh-huh.
And it eventually overwhelms the insulating capacity of the air.
And that's what.
And that's when we get that sudden release of energy that we call lightning.
Oh,
Okay.
I'm with you so far, but we all know the saying, lightning never strikes the same place twice.
Right.
Tell me that's not actually true.
Oh, it's definitely not true. The Empire State Building, for example,
Oh, yeah.
gets struck about 23 times a year.
What?
Yeah, think about it. Lightning is looking for the path of least resistance to the ground.
Okay.
So tall, conductive structures
Yeah.
like skyscrapers, radio towers, even trees are just more likely to be hit.
So the Empire State Building is basically a giant lightning rod.
Pretty much.
It's not just height, though, right? It's also what's in the ground.
You got it.
If the ground is wet or there's a lot of minerals,
Uh-huh.
it's more conductive.
Yeah, it becomes even more conductive.
So it's more attractive.
Yeah.
So if I'm caught in a thunderstorm,
Yeah,
staying away from tall objects and wet ground is a good idea.
definitely.
Yeah, okay.
But, most people don't realize that the dazzling flash we see,
Uh-huh.
that's not the initial strike.
Oh, really?
It's actually the return stroke.
What is that?
It's the surge of current flowing back up to the cloud
Oh, wow.
after a connection is made.
So there's something happening before the visible flash.
Absolutely.
Yeah.
It all starts with something called a stepped leader.
Stepped leader.
Yeah. It's an invisible channel of negatively charged air that zigzags down from the cloud.
Huh.
And when it gets close enough to the ground,
Uh-huh.
a positively charged streamer reaches up from the ground.
From like a tall object or something?
Usually a tall object, yeah. And when those two connect, boom.
Oh, wow.
That's when the current surges upward, creating the bright flash we see.
So it's like a two-way street
Exactly.
with
Yeah.
the leader going down and the return stroke coming back up.
Exactly.
And that happens in like a fraction of a second.
A fraction of a second.
Wow, it's mind-boggling how much is happening that quickly.
It is. It is.
Speaking of quick, we've all heard that.
Yeah.
You can estimate how far away a storm is by counting the seconds between the flash and the boom.
That's right.
Is that true?
That's right.
Okay.
Light travels way faster than sound, obviously.
Okay. Of course.
So if you count the seconds between the flash
Mm.
and the rumble of thunder
Yeah.
and divide by 5,
Yeah.
you get a rough estimate of the distance.
In miles.
In miles, that's right.
Okay, that's a handy trick. But let's move beyond light and sound. I'm ready for some of the, truly weird stuff.
Right.
What's this about lightning emitting gamma rays and antimatter? That sounds like more science fiction than reality.
I know, right? You're in for a treat,
Okay.
because we're about to venture into some truly mind-blowing territory.
Yeah, it's true. Lightning isn't just about the light show and the thunder.
Right.
It's like a cosmic energy event.
Uh,
It emits radiation across the entire electromagnetic spectrum.
really?
Yeah, so we're talking radio waves,
Right.
X-rays, and yes, even gamma rays.
Gamma rays,
Uh.
that's the stuff of like nuclear reactions and supernovae. What's going on up there?
Well, it's a phenomenon called terrestrial gamma ray flashes, or TGFs.
TGS.
Yeah, and they're these incredibly short bursts of gamma rays
Okay.
that originate high above thunderstorms, sometimes even reaching into the stratosphere.
It seems counterintuitive.
It does.
How does lightning, something happening in a storm cloud,
Yeah.
create gamma rays way up in the atmosphere?
Think of it this way. The intense electrical fields generated by lightning, they act like a natural particle accelerator.
So lightning creates this cascade of high-energy electrons,
Okay.
and they collide with air molecules.
Uh-huh.
These collisions release energy in the form of gamma rays, which then shoot upwards into the atmosphere.
So lightning's like a mini CERN in the sky.
It's a fascinating analogy. I like that.
Wow.
And here's where it gets even weirder. Scientists have recently detected antimatter
No way.
being produced by these lightning-triggered gamma ray bursts.
Antimatter, like the stuff that annihilates matter
Right.
in a burst of pure energy, that's like Star Trek stuff.
It sounds like science fiction, I know,
Yeah.
but it's happening right here on Earth.
So how does that work?
Well, when those gamma rays from the TGFs interact with air molecules,
Okay.
they can create pairs of particles and antiparticles,
Okay.
one of them being positrons, the antimatter counterpart of electrons.
So lightning is creating matter and antimatter in the atmosphere. Does that, like, affect us in any way?
Well, it's still a relatively new area of research. The amounts of antimatter produced are incredibly tiny
Right.
and very short-lived, so they don't pose any threat to us down here.
Okay.
But from a scientific perspective, it's a remarkable discovery,
Yeah.
and it just highlights the incredible energy and the complexity of lightning.
It definitely changes my perspective on those flashes in the sky.
Yeah.
I'm curious, though. We often think of lightning as destructive.
Right.
You know, starts fires, damages trees, power lines.
Yeah, all that.
But you mentioned earlier that it also plays a vital role
It does, it does.
in our planet's ecosystem. How
Yeah.
so?
Yeah, it's true that it can be destructive, but it's also a force of creation and balance.
Mm-hmm.
One crucial role it plays is in the formation of ozone.
Ozone.
That's right.
Okay.
That protective layer in the stratosphere that shields us from harmful UV radiation.
So lightning's actually good for us in a way.
Exactly.
It's ironic, considering its reputation.
I know, right?
But how does that even happen?
Well, when lightning strikes, the intense heat breaks apart oxygen molecules in the air.
Oh.
And then those single oxygen atoms can combine with other oxygen molecules to form ozone.
Oh, I see.
So this process replenishes the ozone layer.
Okay, I had no idea that lightning had a hand in, like, protecting us from the sun.
Yeah, it's pretty cool.
You also mentioned that it acts as a natural fertilizer.
That's right.
How does that work?
Think about the essential building blocks of life.
Right.
Nitrogen is a key component, but most plants
Yeah.
can't utilize the nitrogen gas that makes up the majority of our atmosphere.
They can't just breathe it in.
They need it in a form called nitrates.
Nitrates.
And
Okay.
here's where lightning comes in.
Okay.
Its immense energy can split those stubborn nitrogen molecules in the air,
Okay.
allowing them to combine with oxygen and form nitrates.
Oh.
And then those nitrates fall to the ground with rainwater
Okay.
and fertilize the soil.
So lightning is like a giant natural fertilizer bomb,
It is.
nourishing our planet.
It's a beautiful example of nature's interconnectedness, isn't it?
It is. It's amazing. Lightning, we think of it as this destructive force.
Right.
And it's actually essential for keeping everything balanced.
Absolutely, yeah. It protects us from the radiation.
Yeah.
It fertilizes the soil.
Mm-hmm.
And it even leaves its mark on the rocks beneath our feet.
Wait, hold on. What's this about lightning leaving its mark on rocks? I don't think we've talked about that yet.
Oh, yeah, it's a fascinating phenomenon.
Okay.
So the intense electrical current flowing through a lightning bolt, it generates a strong magnetic field.
Okay.
And this field can actually alter the magnetic properties of certain rocks.
Really?
Yeah, particularly ones containing iron oxides.
Ah.
And these lightning-struck rocks They could be analyzed by geologists
Okay.
to learn about past lightning activity in the area.
So lightning is leaving behind a hidden record of its activity
Exactly.
encoded in the very rocks of our planet.
Precisely, yeah.
We're talking like billions of years of history recorded by lightning strikes.
It's incredible, isn't it? It's another layer of complexity and wonder that we're just beginning to unravel.
It is. That's amazing.
And speaking of history, you want to shift gears a bit
Yeah, sure.
and explore how this awe-inspiring force has shaped human culture and mythology.
Let's do it. From gods wielding thunderbolts
Yeah.
to modern day expressions, I mean, lightning has definitely captured our imaginations.
For centuries, yeah, absolutely.
Yeah, it's amazing to think about something like lightning having such a big impact on human culture.
I know it's a force of nature that's, both beautiful and terrifying,
Yeah.
destructive and life-giving all at the same time.
Right.
It's no wonder that ancient cultures, they attributed it to the power of gods.
Oh, yeah, totally. I mean, imagine seeing a lightning storm thousands of years ago
Oh, yeah.
and having no scientific explanation.
Right.
It must have been like the heavens themselves were just unleashing their fury.
Exactly. It's easy to see why civilizations all over the globe wove lightning into their myths and legends.
Like Zeus, right?
Yeah.
King of the gods.
Yeah, the big guy.
Always depicted with those powerful thunderbolts.
Oh, absolutely. Zeus was not just the ruler of the gods, but also the god of the sky and weather.
Right.
And lightning was his weapon of choice,
Oh, yeah.
a symbol of his authority and power.
It's true.
Yeah, think about those epic stories of him overthrowing the Titans or punishing mortals who defied him.
Yeah.
Lightning was always a central part of the story.
It makes you wonder if those stories were inspired by real events,
I know, right?
Like maybe some ancient king used fire during a thunderstorm to, like, intimidate his enemies.
Yeah, and then the story got embellished over time, and boom.
Zeus is born.
Exactly.
And then you've got Thor, right?
Oh yeah, Thor, the Norse god of thunder.
He's a bit more of a hammer-wielding superhero type.
Yeah, a little bit, but still connected to that raw power of lightning.
Oh, yeah, for sure.
Yeah, Thor's hammer, Mjolnir,
Mjolnir.
was believed to be capable of summoning lightning and thunder, making him a formidable force against giants and other mythical creatures.
Yeah, so it's interesting.
It is.
These myths reflect the deep respect and even fear that ancient cultures had for lightning,
Oh, absolutely.
which is understandable.
Yeah, it's a force to be reckoned with.
It's also fascinating how those ancient beliefs about lightning are still reflected in our language.
Oh, yeah.
Today, like we talk about being struck by inspiration or having a flash of insight.
Uh-huh.
Those are direct connections to those ancient associations of lightning with sudden, powerful events.
It's a testament to the enduring power of these metaphors, right?
Totally. Even in our modern scientific world, we still use lightning imagery to convey those moments of
Yeah,
sudden realization, profound change, or even, divine intervention.
it's true. Yeah.
And lightning has influenced culture in other ways, too.
Oh, for sure.
In art, music, literature.
Yeah, all of them.
Like those dramatic paintings of stormy skies with lightning bolts illuminating everything.
Oh, absolutely. Lightning has been a source of inspiration for artists for centuries.
Yeah.
From Renaissance paintings depicting biblical scenes to contemporary photography capturing that raw energy of a thunderstorm.
And in music, too.
Oh, yeah.
You've got those dramatic crescendos and classical pieces,
Wow.
or even the use of lightning sound effects in rock and electronic music.
Yeah, it's a way to add drama, power, and a sense of the epic.
Yeah, for sure. And, we can't forget about literature.
Of course not.
Countless examples of lightning being used as a symbol in novels, poems, and plays.
Yeah, Frankenstein,
Frankenstein.
a classic example.
Yeah, where lightning is used to bring the monster to life, right?
Right? It's this powerful symbol of creation,
Uh-huh.
destruction, and the blurring of those boundaries between science and nature.
It's pretty incredible how something as fundamental as lightning has managed to, weave its way through so many
It really is, yeah.
aspects of human culture.
It is, yeah.
Yeah.
And it reminds us that even in our modern world, with all our technology and advancements, we're still deeply connected to these forces of nature.
You are, and we're still learning.
Yeah.
We've touched on a lot today. The
Yes.
science, the cultural impact.
It's been a whirlwind.
It has, but I know there are still some mysteries surrounding lightning,
Oh, absolutely.
especially when it comes to phenomena like ball lightning.
Oh, yeah, ball lightning, one of those enigmas that continues to fascinate scientists and the public alike.
It's like a glowing ball of light, right?
Yeah, typically red or orange.
that just kind of floats through the air?
Yeah, sometimes even enters buildings.
I've heard those stories, but is there any, like, scientific evidence to support its existence?
That's the tricky part.
Yeah.
There are a ton of eyewitness reports,
Right?
some going back centuries,
Wow.
but there's very little concrete evidence to study
Mm.
because it's so rare and unpredictable.
Yeah.
It makes it really hard to observe and document.
So is it just a myth, or is there something more to it?
There are a number of theories,
Okay.
some more plausible than others.
Like what?
Well, one suggests that ball lightning is a form of plasma, like a superheated gas that can conduct electricity.
Okay.
Another one proposes that it's created by the interaction of lightning with silicon in the soil.
Silicon.
Yeah, forming these tiny nanoparticles that glow as they burn.
So it could be like a mini sun made of silicon.
I know, it's pretty wild, right?
That's wild.
But the truth is, we just don't have a definitive answer.
Right.
It's one of those enduring mysteries of nature.
It's what keeps things interesting.
Exactly. It drives us to keep exploring,
Yeah.
keep asking questions, keep pushing the boundaries of our understanding.
I love it.
Me too.
Well, I think we've covered pretty much everything there is to know about lightning.
Yeah, I think so.
The science, the myths, the cultural impact.
We've really gone deep.
It's been an electrifying journey, to say the least.
I agree. We've explored the physics, the environmental impact, the cultural significance, and even the mysteries that still remain.
So what's the key takeaway from our deep dive?
I think it's this. Lightning is not just a spectacle.
Yeah.
It's a fundamental part of our planet
It is.
and our human experience. It's a force that can both inspire and terrify, create and destroy.
It's true.
And it reminds us that there's always more to discover, always more to learn.
Well said. Well, I think it's time to wrap up this electrifying deep dive.
I agree.
Thanks for joining us on our journey into the world of lightning.
It's been my pleasure.
Until next time, keep those minds sparking.